Ladies and gentlemen, welcome back to sqadia.com. My name is Muhammad Osama and we are talking about probability and distribution in medical statistics. This specific lecture is about probability, in which we're going to talk about what probability is, what are the basic rules of probability, what is a probability distribution, and we're also going to talk about examples of probability using coin tossing to better understand the concept of probability. So let's start off with probability. What is probability? So the proportion of times an event happens in the long run. For example, if I toss a coin, there's a 50% chance that there would be heads and there's a 50% chance that there would be tails. So that is actually the proportion of the time an event happens. And what is the event? It can either be the heads or the tails, and that is actually the probability. It can be estimated from a proportion calculated in a sample, and as we calculate in, for example, prevalence of the outburst of a certain disease. So, for example, proportion of stillbirths in England in 2006 was 3,602 out of 6,73,203. So dividing that, it gives us a proportion of 0.0054. Now here the probability is calculated as you can see a proportion of the cases as compared to the total population, and the greater is this value, the greater is the probability or proportion of that event to occur. So it is a very small value, which means there is a very less probability of stillbirth in the general population. Probability is also interpreted as relative frequency. For example, let's talk about scoring marks in a test, and we say that a person can score 10 marks, 20 marks, or 30 marks. And if you look at the frequency, most of the individuals score 20 out of the total marks. So we can say that scoring 20 marks out of the total marks, because it has the greatest frequency, has the greatest chance of happening, or it has the greatest probability. So it is advantageous as it enables us to estimate probabilities in an objective way, and that can be beneficial in some cases, but it is not always possible to do that, because, for example, if there are a lot of for example, values and for the variable, and we cannot treat it as a discrete variable, it is continuous, and there are a lot of values, and we cannot point out the relative frequency of all of them, or there are a lot of values for which the relative frequency is pretty much the same, and we cannot judge the probability. So it is not always possible, and we need to find other ways of calculating the probability. Sometimes subjective methods of reporting probability are also used, and in terms of statements such as "I think it's as likely as not to rain today," which means that there is a 50% chance that it may rain or it may not rain, and it is actually based on observing the current weather, which is actually a subjective judgment. There is no objective calculation or background or basis behind that. It is just based on subjective observation, and it may change from a person to person. So for this type of probability, a prior knowledge about the likelihood of an event is important, without which you cannot deduce the probability. If it is quantified, it is possible to combine the prior belief with frequency data to give an updated and arguably better estimate of the probability. The frequency data, as we did in the previous one, and the prior belief, and we can combine both of them. If we can quantify them, it would be better than both. Now, rules of probability. What are the rules of probability? So the rule number one is a probability must lie between 0 and 1. 0 means that there is no chance of a certain thing to occur. For example, if I say the probability of heads to come up when I toss a coin is 0, it means the head would never come up. And if I say 1, then it means that the head would always come up. And if I say 0.5, which is between 0 and 1, it means that there's a 50% chance, or there's a 50% chance that head would come up when I toss the coin. So if two events are mutually exclusive, for example, if I toss a coin, so it either comes as head or tails, they're mutually exclusive. There's no overlap between them. So they cannot both happen. Only one of them would happen. For example, if I toss a coin, it would either be heads or it would either be tails. The probability of either happening is the sum of individual probabilities. If two events are independent, then the probability of both occurring is the product of individual probabilities. That would happen in case if I toss two coins, and then that can be calculated. But for that to be understood, we are going to take an example in the upcoming slides, but we are going to keep it on hold right now. That how, if two events are independent, then the probability of both occurring in the product of the individual probabilities. So we're going to discuss it in the upcoming slides. So let's interpret the rules that we discussed. We already interpreted them a little bit, but let's do it a little bit more. So the point one was that the probability lies between 0 and 1. So if a probability is 0, then the event never happens, as I gave you the example of a coin. And if it is 1, the event would always happen. The second is, if two events are mutually exclusive, then only one can happen, as I gave you the example of coin. Either they would be heads or either they would be tails. And another example of this mutually exclusive event would be, for example, death and survival, which are mutually exclusive. A person can either be dead or a person can either survive. There cannot be an overlap between the two. A patient cannot both survive and die at the same time. Moreover, the last point, the last rule of the probability was, if two events are independent, then the fact that one has happened does not affect the chance of the other event happening. So let's take an example. A woman getting pregnant. Now there is a chance for it, there's a probability of it that a woman may get pregnant, and there is a probability of having a white Christmas. Now these are two different events, and they both may have their own probabilities, but they are independent of each other. So increasing the probability of having a white Christmas would not increase or decrease the probability of a pregnant woman giving birth to twins, because they are independent of each other. So these two events are unconnected, since the probability of giving birth to twins is not related to weather at Christmas, because they are both independent variables. And what are independent variables? We already discussed in the previous section, which are not dependent on each other. But there are dependent variables as well. For example, weight is dependent on height. Increasing the height will increase the weight as well. So let's take a deeper look into the probability for a better understanding by using an example of coin tossing, because it makes it pretty easy to understand that what probability actually is. So let's take the example of tossing one coin. So it can be either heads or either tails. Now these are two mutually exclusive events. It can either be heads or it can either be tails. If we toss the same coin several times, then we will get some heads and some tails, and the number of heads that we get or the numbers of tails we get would be a lot similar in frequency. So that is because it's a fair coin. And the probability of head is 1 by half. Like for example, there's a 50-50% chance that there would be probability of head to turn up, and there is a 50% chance that the probability of tails to turn up. So the probability is 0.5, because there's a 50-50% probability for both heads and tails. On the other hand, if I toss two coins, now I have 4 possible outcomes instead of 2. And how is that? Because it is possible that there would be a heads on both the coins. It is possible that there would be a tails on both the coins. It is possible that there would be a head on first coin and tails on the second coin. And it is possible that there would be a tails on first coin and heads on the second coin. So all are equally likely. So the probability is 1 divided by 4. 1 is the maximum probability, so we have 4 possible outcomes. So 1 divided by 4, we get 1 by 4 or 0.25. So there's a 25% chance that it would be a heads. There's a 25% chance that there will be head tails, or 25% chance tails head, and 25% chance tails. As these two are pretty much the same, that one is one head and one tails, so we can add the probability of both of them and it become 25 plus 25% gives you 50%. So there is 25% probability that it would be both heads, 25% probability it would be both tails, and a 50% probability that there will be one head and one tail. So each toss of the coin is independent, so the outcome for the first coin toss does not affect the outcome for the second coin toss, and it actually relates to the third rule of probability. So it can call it, if we look at this, so as I already explained, so probability of head is 0.25%, probability of single head is 1 by 2 if I talk about a single coin, and then another single coin it's 1 by 2, so 1 by 2 into 1 by 2 it becomes 1 by 4. Now on the other hand, probability of one head and one tails is actually 1 by 4 for both of them, but when I add them it becomes 2 by 4, which is equal to 1 by 2, which is equal to 50%. So there's a greater probability of one heads and one tails than the individual both heads and both tails. Now probability distribution, now that probability that we calculated can also be represented in the terms of a graph, and that graph is actually known as a probability distribution. So it is actually a set of exclusive events that includes all events that can happen, and sum of probabilities is equal to 1, because as we already mentioned in the previous slides that the probability lies between 0 to 1, and set of all possible probabilities make up for a probability distribution. So here we have 5 different outcomes, 0, 1, 2, 3, 4 in this probability distribution, for example, and the probability of the 2, which is the random variable, which is x is equal to 2, it has the greatest probability of occurrence because it's around 0.4, which is the greatest for all of them. Now, we were talking about the examples of coin in which we tossed one coin and it was either heads or it were either tails, and there was a 50-50% distribution or a 0.5 probability. So here we can see we have number of heads, like 0 means that we have no heads and 1 means that we have heads. So the probability is same for both, which is 0.5 or 50%. So we can see that this length of this bar or this line actually tells us about the probability. So we had 2 possible outcomes and both of them had the same probability. So this is how the probability distribution is going to look like. The second example in which we use 2 coins, so we had 4 possible outcomes, and here we can see that we have only 3 possible outcomes in the probability distribution, and that is because there was heads tails, tails heads, and tails tails. So heads tails and tails heads, tail heads, it was the same thing, which means 1 heads and 1 tails. So the probability of both of those outcomes was combined and added. So 1 means that 1 heads and 1 tails, 0 means no heads, and 2 means both of the coins show the heads. So here we have 4 possible outcomes, but here we have 3 different options. So no heads, 1 head, and 2 heads. And as we can see in the previous example that we discussed, that the probability for 1 tail and 1 head was 0.5 or 50%. So here you can see it has the longest line, and which is corresponding to probability of 0.5. 0 on the other hand corresponds to 0.25, and 2 on the other hand also corresponds to 0.25 because both of them had 0.25 or 1 by 2 probability, and this had 0.5 or 1 by 2 probability. Now probability distribution is discrete since the number of heads is a count. So each possible value of number of heads is associated with a particular probability and is shown as a vertical line. So the greater number of outcomes, the greater number of options we have, and that you can see the type of the probability starts to change. And as the number of coin toss increases, more lines and binomial distribution begins to take a stronger shape, like a bell. If we join all of them, we get a sort of a bell shape. So for example, distribution of number of heads out of 4 coin tosses, we would have 16 possible arrangements or outcomes. And increasing the number of heads, we would have increased number of outcomes, and then we would have more lines on the probability distribution graph, as we can see here, because for 2 coins we had 3 lines, and here we have 4 lines. For 1 coin we have only 2 lines. So that was all about probability, and we're also going to talk about the types of probability distributions in the upcoming lectures. So stay tuned to sqadia.com for more lectures like this. Thank you very much.